Yes, good morning. Welcome to my pitch deck presentation of seed investment for my traction stage startup. Myself, I am Professor P.K. Praveen Kumar from Department of Biotechnology, Sri Venkateshwara College of Engineering. And I'm also a Chief Executive Officer and founder of Phyto Nanostruct Technologies. So my team members include two PhD scholars. One is MS Preeti J, who is a PhD scholar and of course a co-founder of this Phyto Nanostruct Technologies Private Limited. Along with her, three more, one scholar and two more final year UG students are working under this title called Philantin, a sustainable drug and drug adjuvant for dendritic cell therapy for triple negative breast cancer. So in this slide, we can discuss on the founders of startup. As I mentioned, I am the founder and Jay Preeti, a PhD scholar, she is the co-founder of this startup. And this startup is started because of funding generated from ASD Yukti 2.0. So under this scheme, we have secured around 5 lakhs. And whatever we secured 5 lakhs, this we are using for beginning the startup, for incorporating the startup, and to run the startup for this financial year. And actually, 135 innovations secured grants out of 1,05,000 submissions in India. So we are one of the 135 innovations who secured grant and incorporated a startup from the funding. And about this startup, this is a DPIT startup, India recognized and this is a healthcare startup, and the industry is basically focused on healthcare and life sciences. The date of incorporation is on 17th December 2000. Yes, in our company, we have two divisions. One is manufacturing division, the other is the training division. So the manufacturing division, of course, recognized by DPIT, and the training division recognized by MSME services. If you see this manufacturing division, we are synthesizing around 26 different secondary metabolites from six Indian medicinal plants. Whatever we synthesize in three different purity levels. One is above 50 percentage, above 80, and above 95 percentage. So based on the price, low price to the high price, we are providing these kind of products. Other than the secondary metabolites, we are also conjugating with nanopolymers to produce in the form of nanodrugs. So whatever we synthesize and we commercialize these products are we selling it only for research chemical grade. It means that we can use these drugs for in vitro and in vivo research study purposes. And this can be used for treatment of various diseases like cancer, stress related, rare and autoimmune diseases. In addition to that, we are also offering root and root powders and also the plant-based materials from our SVC soil campus. We are growing these plants and we are selling these kind of products. Now let me go to the training division in Phyto Nanos. We are offering numerous internship and certificate courses for the participants in India, so who like to train related to our manufacturing division services. So, and these services are recognized by MSME Government of India. In this slide, we can able to see the herbarium of phytonanos from Sri Venkateshwara College of Engineering. We are sowing the seeds from the farmers and then we are cultivating the plants. And also for your information, our startup has incubated in Sri Venkateshwara College of Engineering Entrepreneurship and Incubation Center. So we are growing the plants and we are taking the roots and the other plant-based materials. And whatever we take these plant-based materials, we isolate the specific secondary metabolites by standardizing the protocol, whatever we have developed. And then we are also conjugating with nanopolymers to produce in the form of nanopowders based on the customer requirements. And also we are providing with various levels of purity, as I mentioned in the previous slide. So we are selling around 26 secondary metabolites like this. And in this slide, we can see the process and product developed from our company. So we start from the plant and we take the plant-based materials, we grind it, and then we soak it in the methanol and we go with the cold maceration extraction process. Other than that, we are also using the substrate extraction. We use polar and non-polar solvents based on the extraction of polar and non-polar compounds. And we filter the extract and then we purify using the HPLC present in our soil, in our campus. And then we go with the FDAR for characterizing the functional groups of the phytochemical compounds. Later, we conjugate using the nanopolymer using the green synthesis technique, and then we centrifuge, and then we collect the kind of a nanopowder, and whatever we collect, we go with spectral analysis, and then we finally go for storage as well as we go with the lyophilization, that is freeze drying the samples. Then we go with the characterization of the nanoparticles using the GT analyzer and DLS. So we are whatever we are synthesizing the products, we are also testing in vitro and in vivo studies, which the facilities are available in SVC, Department of Biotechnology, SVC, and these are the facilities of our incubation center. You can see almost all the major equipments and instruments are available to work with these kind of experiments. So about the present problem statement, we are pitching for developing a drug, a more precise drug for triple negative breast cancer, which we also call it as TNBC. You know, the breast cancer is the leading feminine cancer in the India as well as in the world. So how is it caused? Just because of uncontrolled growth of abnormal cells in the breast tissue. Triple negative breast cancer accounts for around 12 to 20% of breast cancers, and this shows a complications in treatment just because the absence of estrogen, progesterone, and HER2 receptors make this kind of a cancer most aggressive and difficult to treat when compared to other subtypes. And if you see the 5-year survival rate is just 75 to 78%. It means that 23 to 25% of patients are not getting cured. Okay, they are getting some kind of a side effects even after the treatment. So how we are going to solve this problem? So I am proposing that we are going to use a standard kind of an immune checkpoint inhibitors like heat shock proteins. So whatever we going to try is a plant compound called phylantine. The phylantine we try as a competitive inhibitor for HSP90. As I earlier mentioned in this picture, you can able to see that stage 3, stage 4, the 5-year survival rate is gradually reduced. To improve the survival rate, we can use our kind of a solution. So if you see the problem statement more specifically, only 7 in 10 patients are cured from triple negative breast cancer. It means that we got able to save the 3 patients out of 10 patients. And in this case, we need a precision drug design, which is a major concern. And if we see the first innovation, what we make is to target only cancer cells. If breast is affected and right breast is healthy, we have whatever drug we provide, it has to target only the left breast and not the right breast, so that even the consumption of the drug will be reduced, and even it is more site specific targeting kind of phenomena you can observe. So, and also you can see to avoid pain, okay, we are using this kind of an innovation. For this, the first innovation we are proposing to use mitochondrial targeting, like whatever uh, whatever left lobe is getting affected, then obviously you can see more mitochondria is present in that abnormal cell proliferation location, that is in the left breast when compared to the right breast. So whatever drug we are going to synthesize is going to target the mitochondria so that it targets only the diseased tissue and not the healthy tissue. And we are also proposing the second innovation to target the prognosis and diagnosis marker of triple negative breast cancer. In our case, we are focusing on the heat shock protein 90 alpha, which is a prognosis marker. It means that In the initial stage, in the stage 0 itself, we can able to detect the breast cancer. And of course, we can able to treat in the beginning stages so that we can avoid it in treatment in later stages of triple negative breast cancer. And our third innovation is to establish the method or protocol to lower the cost of isolation, purification, and characterization of the phytochemical secondary metabolite drug, that is phylantine. The phylantine is a lignan compound from Phyllanthus neruri. In Tamil, we call this as Keela nelly. The Keela nelly is grown everywhere. Okay. And this is actually a waste weed plant we just throw. And whatever waste weed plant we throw, we can use this kind of a a plant material, and we can synthesize a cancer drug, a more potential cancer drug called phylantine A lignan. Okay. We have also established the protocol in SVC, and we are utilizing this kind of in vitro and in vivo experiments. We are checking this in vitro and in vivo experiments. Our proposed innovation is also to check the differentiation and maturation of dendritic cells by treatment of phylantine, and to use the same through dendritic cell therapy. So phylantine itself can be able to combat the cancer. Other than that, we are also using this to differentiate and mature the dendritic cells to make these dendritic cells in the form of dendritic cell therapy. The dendritic cell therapy is somewhat cheaper when compared to the existing CRT, chimeric antigen receptor therapy. So if we want to increase the 5-year survival rate, we can able to utilize all these four innovations to reduce the percentage of fatality in Tamil Nadu as well as in India. As I mentioned you earlier, Phyllanthus neruri in Tamil called as Keela nelly. This is grown in wide areas in Sri Venkateshwara College of Engineering. Especially you can see these kind of plants in the wastelands. And this kind of a waste weed, we can use the protocol to isolate, extract, and purify in SVC in a very lower cost. And but we get only 0.1% yield. But whatever waste we get, we are instead of polluting the environment, we are going with a sustainable kind of synthesis techniques to get this kind of a drug compound. And if you see the existing drug doxorubicin, which is a known drug for the treatment of triple negative breast cancer, has side effects with respect to different toxicity. That is, it is toxic to nephrons, that is kidney, neurotoxicity, both central and peripheral nervous system. It can affect this kind of a system. And it's also affecting the heart, that is cardiotoxicity. So this kind of adverse effects can be overcome if we can able to treat this doxorubicin along with phylantine, which may give a synergistic treatment. So in our lab, we are working on these kind of an experiments. And the next thing is this extracted phylantine compound can also be used to pulse dendritic cells, as I mentioned earlier, so that we can able to create our kind of a dendritic cells stimulated with phylantine, which can be used for dendritic cell therapy for triple negative breast cancer. And if you see the cost-wise effects, the dendritic cell therapy is 1.26 lakhs per dose. But if you go ahead with the chemotherapy, it is cheaper, but you can't able to target all the patients. And if you see the CRT therapy, which is very expensive when compared to dendritic cell therapy. So I suggest instead of relying on CRT, we can go ahead with this dendritic cell therapy. And we are providing a solution from the treatment with phylantine. And problem statement, triple negative breast cancer is more aggressive because it lacks the three important genes, okay, major genes which causes the breast cancer. If so, we are going to use a synthetic HSP90 instead of using synthetic HSP90 inhibitors. We are using the natural HSP90 inhibitors to reduce the side effects and adverse effects. Empathy campus. So triple negative breast cancer patients accounts for 50 to 20%. Predominantly, it occurs in women less than 40 years who lacks these three receptor ER, PR, and HER2. So, to increase this, we are using a plant-based medicine as well as a dendritic cell therapy for the treatment. cost burden. If you see, if we treatment using chemotherapy is cheaper, 3.75 lakhs, but this is painful, and this painful kind of a therapy can be reduced, and even it can be more precisely targeted using this targeted therapy, especially through the dendritic cell therapy. Of course, antibodies can also be used, but it gives just a humoral immunity. But the dendritic cell therapy can give both humoral and cellular immunity, so that we can able to increase the 5 year survival rate. And if you see the CRT therapy, it accounts around 45 lakhs. The total therapy is not more than 15 lakhs in breast cancer therapy, but the CRT is more than three times the price of the existing breast, the breast cancer treatment using dendritic cell therapy. And scientific rationally, as I earlier mentioned, the philanthrin is having very lowest toxicity. So whatever you want to counteract the toxicity with respect to neuron, respiratory toxicity of doxorubicin can be nullified, or even we can get a synergistic effect with respect to the treatment of triple negative breast cancer. We also worked on computational studies, and from the studies, it is proven that the philanthrin can be able to use it as a drug for the treatment of triple negative breast cancer. Of course, we have completed part of in vitro studies, and we also confirmed the philanthrin can be able to cure triple negative breast cancer. The cost sustainability. So our price is very, very less. That is 10 milligrams accounts for around 2000 rupees. And whereas if you go with the procurement from branded sources like Merck, Sigma, Aldrich, it accounts for minimum of 50,000 for 10 mg. So the price you can see the United States dollars 370 for 10 milligrams from another company called Medchem Express, where they are also asking for the shipping and handling around $150. So it's more expensive if we procure from the markets, more than 10 times, more than 20 times the price, whatever we are selling. So I suggest you to follow us and support us through seed investments and through grant funding schemes. And related to sustainable resource management, as I earlier mentioned, we are using green technology. That is, we are using a waste weeds, and we are drying the kind of plant-based materials, and we are synthesizing these secondary metabolites. And we are conjugating with nanopolymers. That is, we are implementing the nanotechnology for efficient drug delivery. And of course, we are using a mitochondrial targeting technology and rational. So if you see, the project objective is to evaluate philanthrin as a natural modulator of HSP90 alpha and HSP75, also called as TRAP1. And we are investigating this kind of an expression through RT-PCR experiments, and we assess the dendritic cell activation and tumor immune interaction through microarray, so we can use the microplate reader and RT-PCR assays. And we are also using fluorescent activated cell sorter to check the stages of dendritic cell activation and maturation. We are also performing the computational studies, and then we are working on the synergistic effect in vitro studies, and later we'll be working on in vivo studies. Validation plan. So this is the plan. We have to harvest the plant, and we have to extract the compound. We have to stimulate the monocytes to differentiate into mature dendritic cells, and whatever dendritic cells we prepare, we go with the FACS analysis, we co-culture with the triple negative breast cancer cell line like MCF7, and then we assess the gene expression through RT-PCR analysis. We also analyze the apoptosis, we check the apoptosis through apoptosis assays, and finally we validate the results using the statistical analysis. So this is the plan we are carrying out in our lab. And the technology workflow, like however I explained, start from the plant and come with a kind of a above 50 to 95 percentage HPLC pure secondary metabolite powder. And obviously, we check with the in vitro studies, and also we have tried with in vivo studies. Business model canvas. We are producing very low cost philanthropy as we establish the protocol And even we are not procuring any kind of a plant-based materials. We are just using the waste wheat plants grown in our soil campus. Like, however, we found like in SVC soil. So in Tamil Nadu, we have vast lands, okay, waste lands, and using we can face these kind of plants, and instead of burning and polluting the atmosphere, we can able to extract and purify the anti-cancer compounds from these plants. So we reduce as much as possible in commercial. We are bringing a precision-based medicine for the treatment, as well as we're bringing the precision-based therapy for the treatment of triple negative breast cancer. So we are providing a lot of opportunities for TNBC patients to increase the 5 year survival rate. And we are also using the researchers, and we are providing opportunities for that. The SWOT analysis for Phylantine. So our strengths, we reduce the relapse and resistance. We are using a green tech focused the sustainable manufacturing technologies. Market analysis. So in Tamil Nadu, we can able to see it accounts for 733 patients, and out of top three states which faces the triple negative breast cancer, Tamil Nadu stands second. So we have a lot of patients. So to treat these kind of a patients, so one can able to afford the kind of a medicine or therapy, whatever we are providing from our startup. Global market analysis of triple negative breast cancer therapeutics is huge, nearly $36.64 billion. Where in global market they require these kind of products. The market customers. So whatever we synthesize these research chemical grade drugs, we can able to sell in the companies like pharmacy companies, or we can sell to the chain companies like Sigma Rich, Patanjali, or we can sell to the companies. I mean the colleges, the research institute colleges like SRM, Satyabama. We can also sell it to online retail stores and then convenience stores. So these are the customer segmentation for our products. Major competitors are shown here. So we have competitors from China, New Delhi, Ahmedabad, Bhopal. So in Tamil Nadu, very few are focusing on this. So our startup majorly focus on the synthesis of these kind of a drugs and therapy. So the competition is less when compared to the other states. Competitive landscape. So here you can able to see whatever dendritic cell based immunotherapy the technology we produce, this can act like a key player and specific for breast cancer. You know, there is a vaccine called Denvax, which is used for treatment of breast cancer. So even the Denvax vaccine, if we try with this kind of a plant-based adjuvants we have developed, it can able to cure better when compared to the present existing adjuvants. On competitive landscape, so these are some of the companies who supply drugs for the cancer. And for this kind of a triple negative breast cancer, we are still using doxorubicin, which is having the side effects. So one can able to nullify or try to provide the synergistic effects by treatment with synergistic effect with philanthropy. So our uniqueness is we are using obviously four types of innovations to increase the survival rate. Traction. So if you see the demand for novel triple negative breast cancer therapies is critically high. Over 70,000 annual TNPC cases in India with 85% unable to afford 3 to 5 lakh per month immunotherapy. So this can be overcome from the solutions whatever we have established. Key partners. So we link with NIRT, National Institute for Research in Tuberculosis, CHETPERT, for facts analysis and also for utilizing the immunomodulation experiments. And the VHS blood banks is providing us the perfect food packs that is a source of dendritic cells. So Ramachandra Institute of Higher Education and Research, Kuru, is supplying us the cancer cell lines to work on the effect of the dendritic cells on triple negative breast cancer. And IITM, we are using the high-tech instrumentation facilities, especially like the preparative HPLC, and we are also using the drug delivery techniques in IIT Madras, Chennai. And Sri Venkateswara College of Engineering, we have plenty of uh, we have plenty of equipments and instruments to work with in vitro, in vivo, as well as in silico. We require 15 lakhs grant for procuring lyophilizer and refrigerated centrifuge. The anticipated funding is around 15 lakhs, and we require this lyophilizer and centrifuge for 4 lakhs. And other than that, we require for research and development around 3.5 lakhs. So totally, we require 15 lakhs funding, and we can able to generate around 5 lakhs per, per year. And related to team members, so myself, I am a team leader and a founder, and my mentor is Dr. Balu Ranganathan, who is a founder and director of CANBR's Therapeutics. He is also the winner of Big Pira grant. He secured 50 lakhs for developing the breast cancer therapeutics. And he incubated his company in IITM Research Park. And another mentor is Professor M. Sivanandam, who is a former director of St. Vincent Hospital, New York, USA, as well as he is also a former director of New York Medical College, USA. He already worked in melanoma vaccines and received USA patent in 2001. And these are my team members. Birth and evaluation. Initially, we received funding from ANR Thari, and I worked in IIT Madras, Chennai. So to develop the plant-based drugs and to check the effect of these drugs in vitro studies for the treatment of the hepatocellular carcinoma, which is a primary liver cancer. Later, after receiving a funding from AST and MIC and Arithmetic 2.0, I've incorporated this startup, and after incorporating the startup, immediately I've published and received the grants for two different applications for two different application designs. And we also are registered for trademark for the company logo. And we are completed synthesizing the nano drugs, and we are in the early traction stage. We are selling the drugs to the various customers after receiving the requirements from them. And then these are the design patents granted from our company, Phyto Nanostruct Technologies. And this is related to trademark we have applied. And we also registered in Startup TN in 8th January 2025. The smart card number is also mentioned here. We require a kind of a support with respect to funding. And of course, from the funding, we can able to apply for, I mean, we can able to file and take steps for grant of Indian application patents. So we can commercialize the products and we can increase even the number of secondary metabolites. So instead of 26, we can also increase up to the 100 secondary metabolites from the technology and facilities established. And soon we'll be receiving the standards for OI standards from Bureau of Indian Standards. So these are some of the references. So I thank you for providing me the opportunity to request you for 15 lakhs. So kindly provide us the minimal amount for supporting our startup and to raise the funding through equity based. So thank you. Have a great day to you all.